Today we are going to take our topic forward. In the previous lesson, as you are aware that we discussed about the measures of center tendency. In the previous video, we discussed about the mean and the mode of the given frequency distributions. In the class 9th as well, we have calculated the mean, mode, and the median of the given frequency distribution. But in class 9th, we have dealt with the ungrouped frequency distributions. As in the earlier lecture as well, we discussed that in class 10th, we have to deal with the data which has grouped frequency distribution. Today, we are going to take our topic forward, in which we will discuss in detail how to calculate the median of given grouped frequency distribution. Let us see first what is the algorithm, what are the various steps through which or by which we calculate the median of the given frequency distribution. Let us see what are the various steps first. That's the algorithm of the algorithm how to calculate the median of the given grouped frequency distribution. Various steps that must be remembered are: number one, we have to frame the, out of the given data values, we have to frame the grouped frequency distribution. And then we have to calculate the sum total of the frequency. That is known as the cumulative frequency. And then identify the cumulative frequency group and the group against or corresponding to that particular cumulative frequency. And that group is known as the median class. And after that, we have to use certain values that we calculate from the table, the tabular frequency distribution, and use in the formula. Now let us see first what is the formula used to calculate the median of the given frequency distribution. See, this is the third measure of central tendency that we are going to discuss today. The median of the grouped frequency distribution is calculated as L plus n by 2 minus CF divided by F multiplied by H. Now let us see what are the various parameters that are used in this formula. First of all, here L. L denotes, where we can write, where L denotes the lower limit of median class. Lower limit of median class. Then n by 2, as we are aware, n is the sum total of the frequency, and while calculating n by 2, it will give us the half of the frequency, and by which we can calculate the cumulative frequency later on. And here n is the frequency and n by 2 is the half of that frequency. Now what we mean by this CF? This is CF is known as cumulative frequency, that we are going to discuss in detail. The cumulative frequency of the median, cumulative frequency of the class preceding the median class. Cumulative frequency, we write here preceding median class. Preceding the median class. And then we have F is frequency of the median class. And we must remember that we have to note it down here that cumulative frequency and the frequency, these are the two different parameters. Cumulative frequency is the sum total of the frequencies that we take for the every group in the table, and F is the frequency of that particular class. which is the median class in the given group frequency distribution. F is the frequency of that median class, and H. And what we mean by H? H is the class size. Size of the each group, each of the class that is involved in the given data. This is the formula that we'll use in the numerical problems that we'll take few of the examples from our textbook, from the exercise, and then we'll use, remember this is the this particular result is to be remembered for calculation of the median of the given frequency distribution. Median is equal to L plus n by 2 minus Cf divided by F multiplied by H. Now let us see, while taking one numerical example, how we practically calculate this median of the given frequency distribution. Let us now take one example from our textbook. That will be the exercise number 14.3 is based on the how to calculate the median of the given data. See, the first example in our textbook, I write here, it is exercise number 14.3, and this is question 1 of this exercise. Question number 1. Let us see what are the data values, what it says. The following frequency distribution gives the monthly consumption of electricity of 68 consumers of a locality. We are supposed to find the median, mean, and the mode of the data. In this question, we are asked to find the median, mean, and the mode. In the previous topic, we discussed how to calculate the mean and the mode of the given frequency distribution. Here, what is new for us in this in the today's topic? We are learning how to calculate the median of the given frequency distribution, and the mean and the mode that we will not discuss here, that we have already discussed in the previous topic. That will be homework for you. Now let us see what are the data values here. The following frequency distribution gives the monthly consumption of electricity of 68 consumers of a locality. Find the median, mean, and mode of the data. So what is the data of the consumers of a particular locality? Monthly consumption of the electricity. Here we'll see what is the monthly consumption and what are the number of consumers then. Let us make the table. In this column we will write here monthly consumption. Our variable under study, that is here monthly consumption. Monthly consumption of electricity in units, number of consumers. Number of consumers, and then we will calculate in the third column that we require to calculate this parameter as well, that is a cumulative frequency. Cumulative frequency. Cumulative frequency. Now, what are the various groups that are given here? That is 65 to 85, 85 to 105, 105 to 125, 125 to 145, 145 to 165, 165 to 185, and the last one, that is 185 to 205. Now, what are the number of consumers? In the first group we have 4, 5, 13, 20, 14, 8, 4. Now this is the given data for which we are supposed to find the median. Now let us see how to calculate, how to find the cumulative frequency of the data. Cumulative frequency is the sum total of the frequencies, and in the first one we will write here 4 because we are going to add up these frequencies for each and every group. Then starting with the first group, the frequency of the first group here, that is of 65 to 85, is 4. So we will start with the 4, and then the next will be, we have to add this 4 with the next group, that is 5. So it will be 4 plus 5 will give us equal to 9. Then this 9 is to be added with 13, that is equal to 22. Then this 22 is to be added with the next, that is 20, that will give us 42. This 42 is to be added with 14, that will give us equal, it will be 56. Then 56 is to be added with the next frequency, that is 56 plus 8, which will give equal 64. And the last one, 64, is to be added with 4. 64 plus 4 will give us the total number of the consumers, that is the that's 68. Now as we know, the formula to calculate that we discussed earlier, how to calculate the median of the given frequency distribution. First of all, what are the different parameters? We have to identify the median class here. The median class, how we identify the median class? For that, we'll write here n is equal to, that is the total number of the consumers, that is given here 68. But how we can, as we discussed in the algorithm as well, then we have to calculate n by 2. Why? So because n by 2 will give us the cumulative frequency, and by doing so, we will be able to find the corresponding median class. Let us now find n by 2, that is 68 divided by 2, that is equal to 34. Now among the cumulative frequencies, we have to identify the frequency just greater than 34. You can see just greater than 34, or in other words, what is the other way to find how to identify the cumulative frequency? 34, the first entry here is 4, the cumulative frequency. If we check this 34, it doesn't come under 4. If we check the next frequency 9, this 34, it doesn't still come under 9. 34, it doesn't come under 22 because it is more than 22. Then this 34, if we check this 42, it comes under this 42. Or the first way that how we can identify the cumulative frequency corresponding to this value, that is 34. Here, that is the value just greater than 34, that is here 42. 42 is the frequency that is just greater than 34. Now what we have to do, what is the next step? We have to identify the class or the group corresponding to this particular cumulative frequency, that is this group, 125 to 145. And this group, that is 125 to 145, this will be taken as the median class. Median class is very important to find first in the given table. Only then we can we'll be able to find other parameters that are required in the formula. Here, the median class, we'll write median class is 125 to 145. So this is 125 to 145. This is the median class. And now, out of this median class, what is the lower limit of it? L. L is here 125. That is the lower limit of this class, 125. And then what is the next parameter that is required in the formula? We need CF. CF is the cumulative frequency, but of the preceding class. Preceding class, here you can see the particular frequency we found, that was 42, and this is the group, that is 125 to 145. But the group which comes before this group, that is 105 to 125, and the cumulative frequency corresponding to this group, that is equal to 22. So the value for the cumulative frequency here we will use as 22. This is the important point. What is the value to be used in the formula for cumulative frequency? That is to be remembered. The group which is preceding the median group or the median class, that is to be remembered. So here I am just writing here, this is the CF here. This was the previous particular cumulative frequency, and the frequency preceding the median class. Cumulative frequency preceding the median class, that is here 22. That will use as the cumulative frequency in the formula. And then F. F is also to be used. F. That is the frequency of the median class. You can see the frequency of the median class is here 20. And also we have to use the value of H in the formula. That is the class size of the groups. You can see that can be obtained by subtracting the upper limit with the lower limit, that is 85 minus 65. So that will give us equal 20. And it is uniform throughout the groups. Here we are discussing the class size with the uniform, the grouped frequency distributions with the uniform class size. Now let us see in this data what is the median. Median, we have to write first the mathematical result for that, that is L plus n by 2 minus cumulative frequency of the preceding class divided by F multiplied by H. This is the formula that we'll use here. And this will be further equal to L, that is the lower limit of the median class, that is 125, and then n by 2. N by 2 is here 34 minus the cumulative frequency of the class preceding the median class, that is here 22 divided by F, the frequency of that particular class, that is 20 here, and multiplied by H, that is the class size, that the value is with us, that is 20, which is further equal to 125, and we can make some cancellations here, 20 and 20, and 34 minus 22, it is 12, which will give us the final value, that is the median of the given frequency distribution, that is 125 plus 12, that is equal to 137. And this is the final value, that is the median of the given data. This is how we find the median of the given data while using this particular mathematical formula, and what are the various steps that we discussed in detail. And let us take, this was the practical example that we used here of a particular locality. The monthly consumption of the electricity was recorded, and then we were supposed to find the mid value, that is the median of the given data. Now let us take one more example, that is what are the main examples that are very much important from the examination point of view that we will discuss here particularly. The frequency distributions which have in which we are supposed to find the missing frequencies that we are going to discuss here next. Let us take, that is also one of the important example of our textbook that is to be discussed next. See, in this exercise, in our book, you will find number of examples in this exercise, but some of them will be for your homework to practice at your home to clear your concepts more. The data values, the method will be the same for all the numerical problems, but in that way, the more we try our examples, that our concept will be more clear and will be more confident in our examination to solve these problems. Now let us take some different case in which we are supposed to find the median of the given data. The question, it will be the question number 2 of this exercise. Question number 2. What is the given frequency distribution? If the question says that if the median of the distribution given below is 28.5, find the value of x and y. We are going to write first the class intervals. Then in the second column we find frequency, and then as we know we have to find the cumulative frequency in the third column. First we will write class interval. Class interval, it is 0 to 10. Then for this one it is 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. Then the total in the last one. Here frequency, we have to write what are the particular values. 5, it is x here, that is unknown value we are supposed to find in this particular frequency distribution. Then we have 15, then again it's unknown, that is y, and 5. Then the total of the frequencies, sum total of the frequency is given there, and to calculate the median, as we know, we have to, that is the important column for this, that is cumulative frequency. We are writing with CF. It stands for cumulative frequency. As we did in the previous question, now we know how to calculate the cumulative frequency column. We are going to write the first frequency, that is 5 here, then go on adding the on each and every step the corresponding frequencies of the next classes, that is corresponding frequencies of the next groups. 5 to be added with x, it is 5 plus x, then this 5 plus x to be added with 20, so that will be equal to x plus 25, and this x plus 25 to be added with 15, it will give us x plus 40, then x plus 40 to be added with y, so x plus y plus 40, and the last value will be x plus y plus 45. In this way we have found the cumulative frequency of the given frequency distribution. Now we are supposed to find this particular value, the x that I am encircling here, the x and the y, that is the missing frequency. These type of the problems, these are very much important from the examination point of view. Most of the time you can see the previous sample papers as well. These types of the questions in which the frequencies are missing, or number of times asked in the examinations. So treat these types of the questions as the important for the examination point of view, from the examination point of view. Let us now see what is given here in the question. Here, first of all, we are given median. Here median is equal 28.5. That's given information in the question. Value that we found in the previous example, that is already given here. Now, this will help us to find these unknown frequencies. And now let us see what is the median class. What is the group, what is the class, where this median value, that is 28.5, lies. You can identify it from the class intervals. You can see it, the particular value lies in this group, 20 to 30. And this we will treat as the median class. And this, the corresponding frequency, this will be treated as F, and here this 20 will be the lower limit of the median class, and the cumulative frequency that we will use in the mathematical result, that is this one. As we know that we discussed that we have to use the cumulative frequency of the class preceding the median class. Now, what is the formula that we know? That is median is equal to L plus n by 2 minus CF divided by F multiplied by H. With the help of this result, we are going to find. And before that, as we know, we have to find the value of X and Y. We can compare the total frequency. Here the total frequency is 60, and while finding the cumulative frequency, this X plus Y plus 45 will give us also the total frequency. And X plus Y plus 45, we can compare it with 60, which implies further X plus Y is equal to 60 minus 45, which is equal to 15, which implies X plus Y is equal to 15. Treat this as equation number 1. Later on, while solving this median of the given frequency distribution, and we'll use this the particular value. Now, median. Median of the data L. L is the lower limit of the median class, that is 20 here, plus n by 2. N, sum total of the frequency, that is 60 by 2, minus the, we can use here the square bracket, as we have to insert one more bracket inside. So then we have to use here the value of CF, that is cumulative frequency, that is 5 plus X whole divided by F. What is the value of F? That is the frequency of that particular class, that is 20 here, and then H. H is the class size, that is 10. And also we have been given in the question the median, that is the particular value, that is 28.5, which is equal further, it is 20, and then it is 60 divided by 2 is 30, then it is minus 5 minus X divided by 20 multiplied by 10. Sorry, this is the plus sign here in between. Now, Now let us take our calculations further forward and let us see what we will get. Which implies further it is 28.5, and we can transpose this to left side, that will be minus 20, and some of the calculation can be made here, this 0 and 0, so 30 minus 5 will be equal to 25 minus x divided by 2, which implies further 28 minus 28.5 minus 20, that is 8.5, and we can cross multiply it with 2, that is 25 minus x, which is equal to 8.5 multiplied by 2, that is, this will give us 17, and then 25 minus x, which implies further x will be equal to 25 minus 17, that is equal to 8. Now we have already treated this x plus y equal to 15 as the equation number 1. Now we can use this value, that is the value of x equal to 8 in the equation number 1. So from equation 1 we get, what we will get from that, we will use the value of x, that is 8 plus y equal to 15, which implies further y is equal to 15 minus 8, that is equal to 7. In this way, therefore we write x is equal to 8 and y is equal to 7. These were the two unknown or the missing frequencies that were given in the given frequency distribution that we found by using the particular formula of the median class after making the linear equation, and then we found the value of x and y. Now these are the examples that I discussed earlier as well. These are very important from the examination point of view. Let us take one more example to clear our concept further. This is the data given here is little bit in the different manner, that let us see how to change if the data is the tabular form of the data is given in various forms, that we must be able to convert first those tables in the grouped frequency distribution, and then we have to use the formula that we use as usual in the calculation of the median of the given data. Let us see now, that is the question number 3 of the textbook. The question goes like this: a life insurance agent found the following data for distribution of ages of 100 policy holders. Calculate the median age if policies are given only to persons having age 18 years onwards but less than 60 years. Now let us see what is the table given for us, for which we are supposed to find the median of the data. We have to find the median of the given data in these policymakers. Let us see. It is question number 3 of the exercise 14 point. Here age is given. Now I will make you understand in this question how to convert this to the grouped frequency distribution if it is the less than type of the frequency distribution that we are going to discuss later while we'll discuss the graphs of the cumulative frequency distributions. Number of policy holders, and here we calculate, this will be treated as this is the total of the frequency, this will be treated as the cumulative frequency, CF, and here we will calculate frequency. Below 20, similarly it is given below 25, it is then 30, below 35, below 40, below 45, then it is below 50, then below 55, and the last one, that is below 60. What are the cumulative frequencies? Cumulative frequencies of these groups. Cumulative frequencies are given there. It is 2, 6, 24, 45, 78, 89, 92, 98 and 100. Last one is 100. So this is sum total of that's as we have placed it in the column cumulative frequency. This is total of the frequency here 100. As in the question it says that 100 policymakers. Now how can we find the frequency of these groups? First of all, if we add one more column, we can write the grouped frequency as well, corresponding groups as well here. Age, we can add one more column, we can write it group wise. What is the change that we are making to the particular group, and in the last we can write the frequency. I'm just in the question making you understand that how to convert the less than type of the frequency, in which the frequencies are given like this, below 20, below 25, how to convert these groups first, these age groups first in the grouped form. See, as we are given here below 20, the first value, we can write it as it is below 20. And what is the frequency? That is 2 corresponding to this below 20. What are the age groups that are below 20? Now, while making the groups will be, next group will be 20 to 25. And the cumulative frequency corresponding to this group, that is 6. This 6 means the below 25, the policymakers which are in the age group of below 25, that will the previous group, that is 20 as well. But while we are dividing the given frequency in the grouped frequency distribution, the less than type we are converting into the grouped frequency distribution. Now we have to write down here the frequency of this particular group, that is 20 to 25, more than 20 and less than 25. But to write the particular frequency of this particular group, what we do, we will subtract the previous frequency, that is 6 minus 2, which will give us the frequency of this particular group. That means the previous group is excluded. We are talking about the policymakers which come in the age group of 20 to 25. Those are the 4. And these are the policymakers that is less than 20 age group, that are 2 here. Now, next group will be 25 to 30. As there is a gap of the 5 every time, you can see. So the age groups will go like this: 30 to 35, 35 to 40, then 40 to 45, 45 to 50, 50 to 55, and then the last one, that is 50 to 60. Now go on subtracting the frequencies to find the particular frequency of the respective groups. Now we have 25 to 30, that is more than 25 but less than 30. So it will be 24 minus 6, 24 minus 3, that is 18. Similarly here, from 30 to 35, we are excluding the frequencies which are below 30, that is less than 30, that is 45 to 45 minus 24, that will give us 1 and 2, 21. Similarly, it is 78 minus 45, that is 8 minus 5 is 3, and it's 33. Then 89 is to be subtracted with 78, so that is 1 and 1. 92 minus 89, 92 minus 89, that is equal to 3. 98 minus 92, 98 minus 92, that is equal to 6. And then 100 minus 98, that is 2. These are the corresponding frequencies, and to calculate the median of the data, we have to use the same formula that we used in the earlier questions, in question number 1 and question number 2. First of all, we have to find the n, that is the total of the frequencies, and then divide it by 2, then identify the class just greater than n by 2, and then identify the corresponding median class. And from these age groups, that is group wise now, and from this we can identify the median class, because this column, the age which was to be written group wise, that was very important. Why it was important? Because to determine the median class, because we need to use the value of the lower limit and the corresponding frequency of that particular median class. And this is the table how we can make the change, how we can change this less than type of the grouped frequency distribution, less than type of the frequency distribution to the grouped one, so that it will be easy for us to calculate the median of the given data. That was all about the median of the data. Now let us see what is the next subheading of this topic, that is how to represent graphically how to calculate as well, or rather the median of the that we calculate while using the graph paper as well. I will make you understand in this video as well how to calculate the median graphically. Now let us see what is the what are the various ways how we can draw the graph of the given frequency distribution, that is of the cumulative frequency distribution. Now our next subtopic will be how to draw the cumulative frequency polygons or the curves, or we call them ogives. So that will be graphical representation of the given cumulative frequency distribution. So our topic will be cumulative frequency curves, or we call them as ogives. Before starting the topic cumulative frequency curves, let me brief you about what we have done in class 9th. In class 9th, we have represented the ungrouped data while using the bar graphs, the histogram, and the simple polygons. But particularly here, we have to draw the cumulative frequency curves of the grouped frequency distribution. What is the major difference to draw the simple polygons and the cumulative frequency curves or the ogives? These are more or less the same, the way we plot them, but what is the difference between the simple polygons and the cumulative frequency polygons or the ogives? In case of the simple frequency polygons, we plot the frequencies against the class mark, that's the mid value of the given frequency distributions, mid value of the particular groups against the frequencies of the distribution. But here, what we do in the cumulative frequency curves or the ogives, we draw the cumulative frequencies against the upper or the lower limit of the classes. That's the major and the important difference that is to be remembered, that in case of the cumulative frequency curves or the ogives, we draw the cumulative frequencies against the lower or the upper limit of the classes. Now let us try to understand with the help of one particular example how to draw the various types of the curves. And let us first discuss what are the various types of the methods that we use to draw the various types of the curves in this here. And particularly what we have to discuss here, that is the types of the cumulative frequency curves and what are the different methods we are going to discuss here. Let us see the number one, that is the first one is known as less than method. Less than method. Second one, that is more than method. These are the two graphical methods rather, that we use to draw the cumulative frequency curves or the ogives. Now let us take one numerical example for less than method and one for the more than method to understand this concept. The first one is, the data has been given for the following distribution gives the daily income of 50 workers of a factory. The income of the 50 workers has been given, and we are supposed to, and what is the question for us? Convert the distribution above to a less than type cumulative frequency distribution and draw its ogive. We have to convert the given data into less than type and then draw its ogive. This will be the exercise number 14.4, and this is the last exercise of this chapter. Let's take question number 1 now. Daily income is written there. What are the data values there? That we'll write. Daily income. Daily income is given there. Number of workers. Number of workers. Daily income 100 to 120, 120 to 140, 140 to 160, 160 to 180, 180 to 200. And what are the corresponding frequencies? It is 12, 14, 8, 6 and 10. Now how to convert this to the less than type of the frequency distribution, and then how to draw the ogive of this frequency distribution. Daily income, as we have to convert this to the less than type, I am writing the solution table here. Now let us see how to convert this to the less than type of the frequency distribution. It is daily income as it is given, daily income and number of workers here. Now we have to write here less than, as we have to convert first is to the less than type. This is the group, particular group, it is 100 to 120. It means more than 100 but less than 120. If we are writing it as less than 120, it means less than 120, there is 12, and this group will convert as the group is from more than 120 but less than 140, we'll write it less than 140. But what is the frequency that should be written? That will be the cumulative frequency of the number of workers here, CF, that we are going to plot against these less than type of the data. Now let us see, we have to write here less than 140, less than 140. In this group less than 140, the previous group will be included. That is, we have to add up the frequencies. It is 14 plus 12, that is equal to 14 plus 12, that is equal to 26. 140 to 160, it means we are going to write less than 160, less than 160, less than 160. Previous two groups will also be included, so the addition of the previous frequencies, that is 26 plus 8, which will give us 34. Then we have less than 180, less than 180, all the previous frequency will be included, that will be added up. 34 plus 6, 34 plus 6, that is equal to 34 plus 6, that will give us equal to 40. And then the last one, that is less than 200, that is 40 plus the frequency of this group, that is equal to 40 plus 10 will give us equal to 50. Now let us see how to draw the overview of this data. We have to draw the variable under study, that is the daily income, that we will draw along the x-axis. As we have to start with the value of 120. So as you are aware, we have done in the class 9th as well, we will draw this particular type of the graph, the change we make in the graph, that's this known as kink of the graph. So we'll start with the value 120, then it is 140, this is 160, this is 180, and the last one, that is 200. And the frequencies you can write starting from the 0, this is here 10, 20, 30, 40, and maximum we have to go up to 50. The first one, 120 against 12. So 120 is here and 12 somewhere here. And this graph can be plotted accurately or while using the graph paper. You will try this at home while drawing the particular values exactly on the graph sheet. Now next value 140 and 26. 140 and 26, it will be midway somewhere here. It is 140 and 26, then 160 and 34. 160 against 34, 160 is here. This will be somewhere here. 160 versus 34, this value lies somewhere here. And then 180, 40, 180 against 40, this will be the value. And the last one, that is 200 against 50, 200 against 50. So after joining these points, you can see this is the less than type of the graph of the given frequency distribution. This is the less than type of the graph. Now we'll take next example, that will be the final example to understand how to draw the more than type of the frequency distribution. More than type of the frequency distribution. Let us take the example. It is question number 3 of this exercise. The following table gives production of yield per hectare of wheat, 100 farmers of village. The production has been given and the number of farmers. What is the question for us? Change the distribution to a more than type distribution and draw its overview. Let us take this final example and let us write the data. That is production yield. Production yield is given there. It is 50 to 55, then 55 to 60, 60 to 65, 65 to 70, 70 to 75, and the last one, that is 75 to 80. Since we have to convert this to the more than type, and I will write here the frequencies, number of forms that has been given as well. Number of forms here, that is 2, 8, 12, 24, 38, and 16. Now let us see, I am writing the solution table with this here. You can make the separate as well this table. Production yield. This particular table is the solution table I am writing now here. Production yield, we have to convert this to the more than type. So we have to write more than. In this group you can see this is the group. We can read as more than 50 but less than 55. Since we have to convert the more than, so we will consider here the lower limit, that is more than 50, and the number of forms. Number of forms that will be taken as the cumulative frequency. Then more than 50, you can see total number of forms. It is given in the question that the total number of forms is 100. So more than 50, all these values will be included. It will include more than 55, 50, 60, 65, 70, and all these values up to less than 80. So more than 50, we'll write here it is 100. Then similarly, more than, in this group, more than 55, then more than 60, it is more than 65. Then in this group we have more than 70. Similarly, the last one, that's more than 75. More than 50, 55, 60, 65, 70, and 75. Now, in more than 55, we are excluding the first group, that is 50 to 55. So that is 100 minus 2. The frequency of the previous group is to be subtracted, as we have to exclude it. That is 98. Now, 98. The frequency of the previous group is to be subtracted. Then it is 98 minus 8, that is 90. And then we have 90 minus 12. 90 minus 12, that is equal to 78. Then in this group we have 78 minus 24. So that is 8 minus 4 is 4, 7 minus 8 is 54. Then the last one, it is 54 minus, is to be subtracted with 38. So 4 minus 8, that is 2, 14 minus 8, that is here 14 minus 8, that is here 6, and that's 16. Now these are the cumulative frequencies that we have to plot. Again is the these particular values, more than 50, 55, that is the production yield. Now let us see how to draw the more than type of the frequency distribution of this particular data. Now you can see the data values we have to write here along x-axis. 50, 55, 60, 65, 70, and then 75. Now let us plot these values against the corresponding frequencies. You can write here 10, 20, 30, 40, 50, making the group of tens, 70, 80, 90, and the last one, that is 100. The first one is 50 against 100. This value is here 50 and this will be 100 here. Then 55 and 98, 55 and 98 is here. 98, then 60 and 90, 60 versus 90, this particular value is here, 65, 78, 65 and 78, 70 and 54, 70 versus 54, this value lies here, 70 and 54, and the last one 75 and 16, 75 and 16 somewhere here in between 20 and 10, 75 and 16. Now we have to join these points, and this is the graph that we call as the more than type of the frequency distribution of the particular given frequency distribution. Out of this we can also find graphically the median of the given data, that is the total, the number of policymakers, that the production yield, that is equal to 100. Then we have to take the mid value, and corresponding to that mid value, that is n by 2, which will give us the ordinate. Then accordingly we have to find the x coordinate of it. I am just showing you giving the rough concept how we can calculate the median out of the graph of this particular more than type of the frequency distribution, and the ordinate which is here on the x-axis, that is the production yield, that will be considered as the median of the given data. That we can cross check mathematically as well with the graphical value. In that way we can calculate also the median of the given frequency distribution. So that is all what we have discussed in this video. Here we discussed today how to calculate the median and the cumulative frequency curves, and what are these methods by which we can draw the cumulative frequency curves. And in this we discussed two types of the curves, that is less than and the more than type, how to draw the cumulative frequency curves or the ogives. That was all for today. Hope you have understood well the chapter statistics. Thank you very much.